So here we are on question 7, and they want us to take 3x squared plus 12x plus 5 and write it in the form of p times x plus q squared plus r, finding p, q and r. So we are finding the square of the quadratic. So we're going to start by factorizing out the x squared and the x term, and we're going to look at 3 to take out because 3 and 12 match, and we'll take 3 out, leaving us x squared plus 4x, close the brackets, plus 5. We can then look at halving the 4, giving us 2. So we're going to have 3 and a large set of brackets, x plus 2, half of the 4, squared. Now when we multiply this out, x times x will give us x squared, plus 2x will give us 4x, and we also get 2 times 2, which is 4, which we should not have. So we need to take away a 4. Close the big brackets of the factorization of 3, and we still have the plus 5 on the outside. We are now going to multiply by the 3 again, so we end up with 3 times x plus 2 squared minus 3 times 4 is 12 plus 5, and to finish off we can put together the minus 12 and the plus 5, so we end up with 3 times x plus 2 squared minus 7, meaning p is equal to 3, q is equal to 2, and r is equal to minus 7. The next part is solve the equation. 3x squared plus 12x plus 5 equals 0. So we can straight away say that 3 times x plus 2 squared minus 7 equals 0. And we can rearrange that to give us x plus 2 squared equals 7 over 3. Take the square root of both sides, leaving you x plus 2 equals plus or minus the square root 7 over 3. And now finally take away the 2, plus or minus the square root of 7 over 3 minus 2 for a final solution, and we have two solutions with the plus and minus, which we would expect with the quadratic. Question 8. The function f of x is equal to 2 to the power 2x minus 20 times 2 to the 2x, sorry, not 2x, but to the x, plus 64. And they want to write it in the form of 2 to the power x minus a 2 to the power x minus b, where a and b are real constants, and then they want us to solve it for part b. Okay, so what are we looking at here? We can write the function of 2 to 2x as 2 to the power x squared minus 20 2 to the x plus 64. And what that means is we can say that 2 to the power x is equal to y. And so I can rewrite the whole equation and say y squared minus 20y plus 64 is equal to f of x. If we factorize that now, because it looks like a standard quadratic, okay, we are going to end up with 2y's there, 2y's there, and then we are going to end up with a 16 and a 4. And if we have them as both negative, it will give us plus 64, 4 times 16, and it will add up to give us the 20y, which means that we can now rewrite it back with the 2 to the power x instead of y, and we've got a at 16 and b at 4. So just to finish it off, substituting 2 to the power x in for y, so we have 2 to the power x minus 16, all in brackets, and 2 to the power x minus 4, pen's going strange, meaning that we have a is equal to, it already had the minus in it, 16, and b is equal to 4. Next part is question 8. Hence, find the two roots. Find the two roots of f of x. So, we're going to have 2 to the power x minus 16 equals 0, and we are also going to have 2 to the power x minus 4 equals 0. So 2 steps to solve for two roots. So 2 to the power x is equal to 16, which means x, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. X is equal to 4. And on the right hand side, 2 to the power x is equal to 4, meaning it would be 2 squared, meaning x is equal to 2. So question 11, we are modelling a diver and his height with relationship to the time is modelled as 5t minus 10t squared plus 10. So what do we have there? We have a quadratic that is looking something like, it's going to look something like this, where this is the 10 from the c coefficient, and as the diver jumps, travels up a little bit and then comes in and hits the water. Okay, first question, A. How high is the springboard above the water? A is where HT cuts the y-axis, so 10 meters. Okay, which is just read straight from there, being the c coefficient. Okay, part B. Use the model to find the time at which the diver hits the water. So that would be looking to see where the diver hits the water. We are looking for that route there. Okay, so we can use the formula for this. So the quadratic formula is x equals minus b plus or minus the square root b squared minus 4ac all over 2a. So very quickly I'm going to work out b squared minus 4ac square root of is equal to the square root of b squared is 5 squared minus 4 times minus 10 times c, which is 10, which gives us 25 plus 100, 10 times 10 is 100, plus 400, so the square root of 425. Grabbing a calculator. 5 root 17 is what we are getting. Okay. So 5 root 17 and now we can put that into the rest of the equation. So we get x is equal to minus b, which was 5, plus 5 root 17 all over 2a, which was minus 10, 2 times minus 10, or minus 5 minus 5 root 17 all over 2 times minus 10. Working out both of these, onto the calculator, minus 5 plus 5 root 17 divided by minus 20 is 5.15, or we can have minus 5 minus 5 root 17 and dividing that by minus 20 gives us 1.28. Okay. My apologies, it's not 5.5 on the left when you put it into the calculator correctly. It actually comes out as minus 0.7. So we want our answer here to be the positive 1.28 seconds. Okay, is how long it takes for the diver to hit the water. Okay, part C. They want us to rearrange the equation. Rearrange the equation in the format of a minus b, open brackets, t minus c squared. Okay, so we are completing the square and finding a, b, and c. So let's just write out the equation one more time so that we can see it and we have it there. Okay, and I'm going to rearrange it this time. I'm going to say h as a function of t is equal to minus 10t squared plus 5t plus 10. So again, I'm going to factorize this, and I'm going to take out a 5 that will leave me a minus 2. No, I'm not going to take out that. I'm going to take out a minus 10 from it, so that I get a t squared. So I can take out a minus 10. That leaves me t squared and plus, more to the point, minus, because it's a minus 10 that I'm taking out, minus 5 over 10t plus 10. Okay, this would cancel down to minus a half. Okay, so we end up with a minus 10 times t squared, not t squared, but the t, minus a quarter, half of the half, squared, and that means that we're going to have a positive 16th that we need to contend with, so we're going to have to take away a 16th plus 10. Okay, so multiply back through by the minus 10, so we get minus 10 times t minus a quarter squared plus 10 over 16 plus 10. Putting the 10 over 16 and the plus 10 together leaves us with a minus 10 brackets t minus a quarter squared. That is 1 and what is that? That's 5/8. So it was 10 and 5/8 plus 10 and 5/8, giving us an A, B, C values of B is the 10 in front of here, A is the 10 and 5/8 at the end, and C is what's left in the brackets with the minus on it, which is a quarter. Okay. Using the answer to part C to find the maximum height of the diver and the time at which the maximum height is reached. So because we have done completing the square, we can actually redraw the picture. We know it comes out in parabolic like that. There's your time, there's your height. We know that it hits here at 1.28 seconds. We know that the diver leaves the diving board at 10 meters. And because of the completing the square, we know that the quarter is 0.25 seconds is the time that we hit the maximum of the dive, and we know that 10 and 5/8 5/8 of course being 625, 10.625 meters. Okay, so the maximum height is 10.625 meters at t equals 0.25 seconds.